Hi, this is our Chapter 19 lecture on aldehydes and ketones and their nucleophilic addition reactions. So this was our first official treatment of carbonyl compounds. Remember, carbonyl is the C double bond O, and the chemistry of carbonyl compounds is going to be a major portion of this course, right? 4 whole chapters worth, obviously. So aldehydes and ketones are among the most common of carbonyl compounds. So obviously very important in their usage and application, and we will hopefully get to know their properties very well in this chapter anyway. So let's start with aldehydes. An aldehyde, we know that by now, RC double bond O with an H. Also RCHO. If you ever see CHO, that's an aldehyde. To name an aldehyde, it's going to be very similar rules to alcohols. We'll replace the terminal E of an alkane name with the suffix al, Al. So because in an aldehyde, the carbonyl is always on the end, that's always going to be carbon number 1 of the carbon chain anyway. So here's ethanal, here's propanal, here's a little more complicated compound 2-ethyl 4-methyl pentanal, right? Same thing, 1, 2, 3, 4, 5. Let me draw one with the double bond in it, because that always complicates things a little bit. So just like that. There are 1, 2, 3, 4 carbons on the backbone. There's a double bond between carbons 2 and 3, as well as a methyl group on carbon 3. So we'll start with the 3-methyl. And then the double bond starting at number 2. So 3-methyl 2-butene-al. Aldehydes where the aldehyde group is carbon 1 does not get a number. So the aldehyde group, for instance, does not get a number 1 because it's understood that within a chain of carbons, the carbonyl will be carbon number 1. A little more complicated when we have an aldehyde group that's attached to a ring, although it still ends up being a suffix. So we're not going to talk yet about how to make an aldehyde into a prefix. Hasn't been necessary in any of the compounds we've dealt with yet. So we use carbaldehyde as a suffix if you have a CHO attached to a ring. So here's cyclohexane carbaldehyde, right? CHO attached to the ring. Here is 2-naphthalene carbaldehyde. The only other variation of this that I can think of is when I have benzene with C double bond OH, right? That's benzaldehyde. We've already learned that. So if I put a bromine meta to it, that's meta-bromo benzaldehyde. Right. Aldehydes and other carbonyl compounds typically have a series of common names that are still in pretty wide use. So the 1-carbon aldehyde, it's really barely an aldehyde, H, C double bond O, H, is formaldehyde. CH3CHO is acetaldehyde. So formaldehyde and acetaldehyde, where their IUPAC names would be methanal and ethanal. The structure of propenal is also known as acrolein. 2-butenal is also known as crotonaldehyde. So if you ever run across these names in the future, that's what they are. And then we've already dealt with benzaldehyde, but please do be aware, make sure you know what formaldehyde, acetaldehyde, and benzaldehyde are. I'll just say no, the starred ones. Formaldehyde is pretty much always called formaldehyde. I don't know that I've ever seen it called methanal. Same with ethanal. So have those on the tip of your tongue. Ketones, we name them with a suffix also. We use -one in their names. The ketones, however, do need a locant, a number that indicates the position of the carbonyl group. So ketones will be very similar to alcohols in the way that we've named them. So the location of the carbonyl group will always take precedence over any other groups that we've studied so far. So 3-hexanone, if I have a double bond, the carbonyl takes precedence over the double bond. So carbonyl and carbon 2, double bond between 4 and 5. That is 4-hexene 2-one, right? The number 4 corresponds to where the double bond starts. The 2 corresponds to where the carbonyl is. Multiple carbonyl groups, we name them just like we would do multiple hydroxy groups in an alcohol, right? So we can have a dione or a trione or something like that. So when I have carbonyl groups on 2 and 4 of a 6-carbon chain, that becomes 2,4-hexane dione. Notice the E there, where if I had just one, it would be hexanone without the E, hexane dione, because the suffix starts with a consonant, so we keep that final vowel. For common names of ketones, here's acetone, 3-carbon ketone, CH3, C double bond O, CH3. Here's acetophenone, we've seen it before, a methyl ketone attached to a benzene ring. Benzophenone is 2 benzene rings with a C double bond O in between them. So please know those common names because those are very, very widely used. We can have a ketone be a substituent, whether it's on a ring or a more complicated structure. In general, a R-C double bond O group is an acyl group. That's why we had Friedel-Crafts acylation reactions back in the EAS chapter. So here is the acetyl group. That is a methyl ketone group. Here's a formyl group, C double bond OH. Here is a benzoyl group, right? C double bond O with a benzene attached. So that's what we need to do if we have for instance, a ring with a higher priority group like a carboxylic acid or something at a higher oxidation state typically is a higher priority. So that's what we need to do if one of these is named as a substituent. If we have a carbonyl within a chain, and if the carbonyl has to be named as a substituent, for instance, here's an ester, which has a higher priority over ketones, or that higher oxidation state usually means a higher priority. So this compound would be methyl 3-oxo. If we need to just specify a carbonyl somewhere, we use oxo as a prefix. So here's methyl 3-oxohexanoate.